Hello, this is Steve with Renesas Timing University. In this video, we're going to be talking about jitter attenuators. A jitter attenuator is a PLL that takes this incoming clock, it cleans up or reduces, attenuates the jitter, and it sends that clock to a downstream receiver. Now I'm going to be using this diagram and this equipment to show you how that's done. Now let's talk about the theory. In a previous video on PLL theory, we presented the various components of the PLL, the phase detector, the loop filter, the VCO, and the feedback divider. So let's say we have this noisy clock. Now this clock could be coming from a clock recovery circuit, or perhaps it's coming from some upstream device in a system and it picked up noise along the way. But we need to send a clean copy to the receiver. Now this loop filter, it acts as a low pass filter. It's taking all the jitter from this clock and it's actually filtering out the high frequency noise. So in essence, it's kind of averaging the location or the phase location of this clock and sending out a clean copy. Now let me show you how that actually works by using this equipment. Okay, so here's the setup. I've got a phase noise system which measures the quality of the clock, a generator, and also an evaluation board for our latest device, the Femto Clock 3. So I've connected this generator to the phase noise system, and if we can zoom in, we can see that the phase noise is 983 femtoseconds. And so I'm going to save this trace, and then I'm going to connect this clock to the Femto Clock eval board, and we're going to see the difference that it makes. Okay, so I've taken the output of the generator, I've connected it into the board, the evaluation board, and I've taken the output of the evaluation board and through a bellon, I've connected it to the phase noise system. So let's go ahead and zoom in. And right now the board is running, but the clock is not active. So if we take a look at the frequency, it's just slightly below 156.25. So I'm going to activate the clock. So let's start it up. And we see this phase disturbance as the PLL locks to it. And we can see that's dialed in now to 156.25 exactly, with just a tiny little offset. And I can also adjust the input clock. So this proves that it's locked to the input clock, but I want to kind of show you the difference. So you see this is 65 femtoseconds. So the clock source that's coming in, it's very noisy, but the jitter attenuator is tracking it and it's providing this very, very clean output. So from 900 plus more than 900 femtoseconds down to 64, here we go, 64 femtoseconds. Let me adjust the clock just a little, just to show that it is running. So we're gonna increase the frequency just slightly, and you can see that the frequency has increased. So that's it. This is showing the before and after the output from the jitter attenuator. So thank you so much for taking time to watch this video, and I encourage you to check out more of our videos on Renesas Timing University.